Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is answer to the comments on the previous video. The previous video was called Test Drive Interesting Behavior, and I tried to drive the point that when you are doing test-driven development, you need to separate things that are part of the language, part of the framework, part of the libraries, and things that are not. Things that you actually add on top of the programming language. So the actual essential features that you implement. And it seems that I've done a good job showing an example, but there are also some more questions, some more comments regarding this example, which I only find encouraging. It's good to have these types of conversations, and I hope that more people can learn from these conversations. So this video will be a bit more on a number of topics, and we're going to read through the comments, and I will just try to answer briefly to multiple points because the comments are quite long. But I will try to get to the essence of things. All right, so let's see what we have. First of all, the commenter who asked the initial question, PVX215, he posted a new comment. I hope you are a he. Okay, they posted a new comment. I don't know what you are. Dear Alex, thank you very much for your video reply and demonstration. To follow on my thoughts on your video, and please correct me if I'm wrong. Okay, let's do this. Point 1. I have the impression in your example that you are in favor of using guard clauses in the production code, thus making these checks part of the behaviors of the code functions modules. Is that right? P.S. I likely call this approach as error control, thus in production everything is checked, asserted, and possible errors, unwanted behaviors are recorded and propagated to log lists, thus if happen to be able to follow the flow of how they were generated. So to answer the question, okay, I'm in favor of using guard clauses, but actually I'm in favor of a special type style of design, which I haven't seen used a lot. And I talked about this before, and the style of design that I favor is the one that uses what I call optional types. Basically, what I want to have is what I favor personally, and it's not advice, okay? You don't have to follow this style of design. You may think about it, you may adopt if you want, but don't take it as me saying everybody should follow this style of design. No, this is what I found works best for me. And then it's up to you to decide for your own context what works best. So what I found that I like is a style of design in which I don't do the work of the compiler. So I don't want to necessarily write the types for variables, for arguments, for things, for data members inside objects, even when I can. And this is why Python fits my style best. Of course, if I'm writing C++, I don't follow this style of design, just to clear things out. But if I'm using Python, yeah, I would ignore the types completely, except at the entry point of the system. At the entry point, whether it's the main method, whether it's HTTP endpoints, whatever it is, I am doing everything I can and as much as possible to check that everything is correct. So there I would have types, I would have all kinds of constraints, like make sure that the bounds are correct for the values, make sure that If it's a string, the encoding is the one that I'm expecting. Make sure that we don't have potential security problems like injecting things through strings or stuff like that. So this is where I'm doing a lot of the work that people kind of distribute inside systems. And the reason I like doing that is because I noticed that I don't get in trouble for doing this. In fact, what I noticed is when I'm using optional types, I have to name things very clearly, and this helps me understand code better than types. And the second reason I'm doing this is because it allows the code inside my code base to be more flexible. I can extend it in different ways. I can reuse things like functions that were written for a specific goal, but then I want to use them for another goal, and I would have to refactor them if I were doing the very restricted types things. So this would be the complete answer. And actually in this situation, I will never have an add method like this that restricts positive integers, unless this is the only thing that we can do. But generally speaking, I'll probably have an add with 2 parameters that returns the value, and the verification for are these parameters positive and so on, this would come from the entry point, right? And in this case, probably I wouldn't have an implementation of the add method because it's already in the language. So I have no reason to abstract it. I have no reason to add something on top of it. And then I count on Python to do what it does and say, okay, if I want to add to things, if there's an add on them, then they can be added. And that's all. But this is a very specific style that I think works with very specific circumstances. It's not something that I encourage people to do. It's something that I do, and I talk about it occasionally when I need to clear up things. But going back to guard clauses, let's not confuse. I just want to make very certain that we don't confuse test-driven development with the implementation choices. The implementation choices are very different from test-driven development. Test-driven development is a general process. Okay, using guard clauses is a thing that I prefer if I'm not using optional types. I would either prefer having a kind of design by contract implementation with precondition, postconditions, and invariants. But this is typically very difficult to implement in programming languages, and we have a whole video discussing this. But the other option would be using guard clauses. And the reason I like guard clauses is because they cleanly separate the validation from the actual implementation, the thing that the function does. And I like to have this because I think these are two different concerns. Ideally, I would like the concern for validation to be outside. So, for example, at the entry point of the system, anyway. And the function to just do what it does and not more than that. But these are all different choices that are contextual. And to me, one additional parameter that complicates my explanations is that I always have to think about the experience of the people that are watching these videos. And so I'm trying to explain things in a way that is as general as possible and doesn't that is not constrained by my preferences, my choices, and so on. They occasionally do come through, of course, but yeah, this is why I favor guard clauses. But more than guard clauses, I would favor things that are validated at the entry point, and then the functions are cleaner because they just do the adding part and don't care about all the validation part. Okay. Now, but in this case, I had to make a choice in order to show, the test-driven approach. And the choice was to show it in, let's say, the most generic way that would fit the most styles of programming, whether you do a web application, a framework, library, and so on. Or a script. You can use the same technique. It works. It's not ideal for all these situations, but then it's also up to you who are watching this to make sure that you make the choices that fit best in your context. I'm just showing some examples. Okay, so this is why I'm favoring guard clauses, but very important thing. This has nothing to do with test-driven development. Okay? The implementation choice is not test-driven development. Test-driven development is a very clear process, and let me go back to this because we'll need to discuss it in a moment. So what is test-driven development? It's a method for incremental design, so it's not a method for testing. Important thing. What does it mean to do incremental design? Well, incremental design means that I'm doing design one slice at a time, one behavior at a time. I'm writing and you could do incremental design without test-driven development. Okay? Nothing stops you from saying, okay, so let me first write the add behavior. 2 plus 3 equal 5 would be the example, okay? Let me just make sure that add implements plus. Fine. Now what do we do with checking the first parameter? What do we do with checking the second parameter? And I could do this in the head, basically run the tests in my head. Okay, that's a method of incremental design. And it's different from non-incremental design. How would non-incremental design be? I would read the specification and said I need to add 2 integers, and then I would just write the whole code without necessarily taking one behavior at a time, one example at a time. Okay, and that's probably what most people do. For this method, I don't think the difference is that high between the two approaches. But if you are thinking about a more complex situation, then the difference can be large. I mean, the difference is if you have a function or a class, or basically you need to implement a new functionality. That's where it comes from. And your new functionality is something more complex. I know people who sit down and write code for 4 hours and then run the code. Compile and run, and then they see what doesn't work and then kind of go through the code and figure out what. Okay? That is not incremental design, and that is not test-driven development. It would be incremental design if I would write a small thing that just covers a small piece of the problem, and then I would run it and make sure it works, and then I would think about the next one, write just for that one, run the code again, make sure it works, and so on. And now with test-driven development, it's just a way to make this process simpler, easier, because by having the tests, they just tell me that whenever I'm making a change, I didn't break anything that I did for the previous behavior. Okay, So this is what test-driven development is. It's a method for incremental design with the side effect of having automated tests almost everywhere. But the goal of test-driven development is to solve a problem. It's not to write the tests. Okay? The tests are a tool that we use in order to solve this problem incrementally, and it's a very convenient tool because it helps us cycle very quickly. Which otherwise, if I basically run the tests in my head, I could do this, but probably I will lose track after a while, and that's how we introduce bugs. And now, how does this work? Very important, you write one single test that fails. I will go back to your comment in a minute, but you are mentioning writing tests before a number of times, and that is technically not test-driven development. Test-driven development is you write one single test that fails, and this is what I have demonstrated. Now, maybe it was a communication in your comment, but I really need to clear this out. Then you write the minimal code to make the single failing code test pass, then you refactor, and you do this in a fast cycle that takes generally a few minutes. Okay? Typically this takes 5 minutes, 10 minutes, maybe 15 minutes if it's something more complicated, usually in the refactoring phase. Then there are a few variations to this, which I'm going to go through in a moment, but the important part, the one that is left outside of this red-green refactor cycle, is the think part. Okay. What I have done in the beginning is I have analyzed the problem. Okay. So maybe it would be the problem. You can replace think with analyze the problem. Now, how can you do this? The way I've showed it is by writing examples and ordering them from simple to complex, from with happy path first. But this is just a technique that I showed, and it's a technique that we use with people who want to learn test-driven development. So this would be learning wheels, more or less. Although I know many people who have done test-driven development for years and they still write down the examples first. So maybe learning wheels is not such a best way to put it. It's more like you use anything you can to help you, right? And there's no shame in that. But the other one is just after enough experience, figure out order the behaviors and test order in your head. That's perfectly fine too. Another thing that is important here is whether you are working alone or working with somebody. When you work with somebody, like doing pair programming or things like that, you need to communicate what you are trying to do. And one way to communicate is by writing these examples first. Of course, you could also discuss and decide what is the first test and then what is the next test and so on. And that's it. Now, I've done a few things that were slightly different. And these are variations to the process. Add paranoid tests. Sometimes, okay? So sometimes after refactoring, I would add some more paranoid tests, which I expect to pass. Okay. Example of paranoid tests, I had 1 plus 2 equals 3. I can then have 9,999 plus 1 equals whatever it is. And with this, I would get what? It's just another example. I don't expect it to fail. These are just to ease my mind. Okay, they are not technically necessary. We have already tested that case. But sometimes I would do that. And occasionally when I write these paranoid tests, I find some interesting situations. Not in this case, but occasionally it happens. And then I have a test that fails and so on. You don't have to do this. It's but it is, in my mind, is still test-driven development. It's just a variance of this cycle. Another thing that might happen, you write a single test that fails, and when you try to write the minimal code to make the test pass, you realize that it's difficult to do it, and you actually need to refactor a little bit in order to have a system that allows you to introduce this new behavior. And so what you do is, or what I do, I ignore the test that fails temporarily. I go back to refactoring. I make some refactoring steps in order to make space for the new behavior. Then and the reason I'm disabling this test is when I'm refactoring, I'm still continuing to run the tests. Okay. And then I'm going back here and re-enable the test and kind of go again in the same cycle. That's another variation. Okay, I think that's about it with the different things that I've done here. So as you can see, importantly, an important observation here is that it's nothing here tells you about how to implement the code. So whether you use types like unsigned int or guard clauses, or you make no validations inside the function and the validations are outside at the entry point, those are all decisions that are up to you. The only thing that test-driven development is this process. Okay, that's it. Nothing more, nothing less. What this means is a few things. If you are implementing more than one test and you have more than one test failing at one point, that is not test-driven development. Well, unless you've made a mistake and then you go back and fix it. But if you start by writing, I don't know, 3, 4, 5 tests and then implementing, that's not test-driven development. It's a perfectly fine method. It's called test-first programming. Not as good as test-driven development based on my experience, but no, it's not TDD. So we need to make this distinction. If you disable tests at any point in this process, that's not really TDD, because here I want to run, so write one single test that fails. What this means is one test fails, all the other tests pass. And I'm gonna go back to this point because you make an excellent point about doing this in an embedded context or with things that work very slowly, and that's a different problem. That's a problem of optimization. I'm gonna go to that in a moment. But here, when we say write one single test that fails, we run all the tests and we see that one test fails and all the other tests pass. And here, after each refactoring, so actually here, all tests pass. And in refactoring, we actually have a cycle of refactoring. Okay. And after each refactoring, we run the test. Each refactoring, we run the test. Each refactoring, we run the test. After each refactoring, all tests should pass. If one test fails after refactoring or more, then we go back to a stable point where all tests are passing and do it again and do it right this time, because refactoring means by definition that you don't change the behavior of the code. You only change its structure. This is what refactoring is. And because of this, you only change the structure, like maybe you rename things, maybe you extract the function, but it should do exactly the same thing, which means that all the tests should pass. Okay. Now, what this presumes is indeed that we have fast tests. And I'm gonna go to your comment in a moment because I think it's very interesting. So TDD presumes we have fast tests, which leads us to some problems in optimization, okay? So let's go back to your actual situation. Point 2. Okay, we have another thing. Does this error control approach closes assertion error checks in production with error control mechanisms in my terms? Okay. Indeed requires some mind work as you initially wrote down in your document. As you said, it automatically happens in your mind. But instead of writing the test cases, let's say someone writes directly the error control clauses in the source code. It's easier to think them there as you already work in the context and see types, etc. in every possible operation, which can yield or unwanted results in a code function module. So, okay, I have no problem with that, but it's not test-driven development. Okay, if you're doing this. So test-driven development is about analyzing the problem first, and part of the problem is happy path, what should this function do? And we define the happy path by examples. If we get 2 and 3, we need to get 5 out. If we get 4 and 9, we need to get 13 out. And then there are some equivalent examples, which is maybe what I should be specifying here. When I'm talking about paranoid tests, these are equivalent examples. They will not test anything more, and we know they will not test anything more, but I just want to make sure. And that's actually part of the general technique in testing, which is called equivalence partitioning. There are some rules you can learn in order to do that. Yeah. So basically, but if you want to learn all that, I'm afraid I cannot explain all that in videos, but we have a full learning programs or test-driven development and other things. So contact us on mosaicworks.com and we'll figure it out. So if I'm going here, it's also very important to make the distinction between this part, when I wrote in the text file the list of examples, and actually implementing the test. Okay? When I say here, write one single test that fails in test-driven development, this means you actually write one test code, okay, in using your test library and calling your production code, which doesn't exist yet, or if it exists, it's a new behavior that you are adding. Okay, so you write one single test that fails, you actually run it, you see it failing. This part is just something that helps you start the process. It's not necessary, you can just figure it out and figure the order of things. But it just starts the process. So instead of writing the test cases, let's say summarize directly the error control clauses in the source code. Okay, but it's not test-driven development. Maybe you write the tests after, maybe you don't write tests at all. It's not test-driven development, it's something else. Feel free to do it if it works for you, but it's not TDD. Don't call it TDD. And if you want to understand TDD in detail, unfortunately, I can only explain so much. The only way to do this is to embrace it and to try it. And maybe you could also take a look at the playlist called Alex Learns HTMX, where I'm learning a new technology using test-driven development. And if not, you can also search for other, for example, if you search for my brother, Adi Bolboaca, also appears in many of our videos. He also did a lot of, on his website, he has a lot of examples of the process. Okay, an issue with this error control approach can arise only to time memory critical system. In such cases where no error control mechanism can be implemented, TDD is the only alternative. Test before production, not be able to test in production. I don't get this because I feel there's a confusion in what TDD means for you. But let's say you have a suite of tests. So I'm separating test-driven development for having a test suite. You can have a test suite in any number of ways. One way is to do test-driven development, which means you write one test, you write that fails, you write the code to make it pass, you refactor. You write another test that fails, write another implementation to make the code pass, you refactor, and you go like this in a cycle until you have covered all the behaviors you need. You can have a test suite by adding tests on existing code, and that's a different problem. And we discussed it in a video called Can You TDD on Existing Code? You can have a test suite by writing the code and then writing the tests, and that is called test after. Sometimes the tests are written by programmers, sometimes they are written by other teams. Okay, I wouldn't advise this because it tends to be annoying and miss on a lot of things, but people do that and you still end up with a test suite. You can have a test suite by writing first all the tests that you think about for a specific behavior and then implementing the code, and this is called test first programming. So It doesn't matter. Well, it does in the sense that I think with TDD you tend to get the best test suites. But let's assume that no matter what method you are using, you end up with a test suite. Now, if we are talking about time memory critical systems and so on, what I understand by this is that you have some limitations in memory, but you can still split. So the way these things tend to be tested, and that's a testing strategy, which is a different, a higher level idea. You take the whole system and you try to separate out things that are related to the operating system and things that are not. And those things that are more portable, you can test them outside of the device or the operating system that you're trying with. I did some work with teams that were doing RTOS. If I remember correctly, that was the name. So real-time systems. And that's basically what we did. So we split the two. And okay, you have some things that are the interface between your behavior and the time, the real-time system. And then you have a simulator where you can run these programs and where you can also run tests and where you have more control and they can go faster. And you can also run tests for parts of the code on your own computers, on your own PCs or laptops or whatever, and on integration machines which are more powerful and so on. For those things that are in the code but that are not directly related with real time or with the operating system. So, and you end up with a testing strategy that tries to weed out things. And of course, it's not ideal because you might end up with, so it's not ideal, but it enables you to do test-driven development, because what you can do is for the things that are not directly related with the operating system, you do your TDD cycles. And of course, you take into account the constraints, like you cannot have guard clauses or things like that because time sensitive, whatever. But those are constraints on your design. And you do test-driven development on your own PC. You can run a lot of the tests that only touch things that are separate from the operating system. And you do that, and then you move to the simulator, and then you run integration tests, which check that, well, the glue code between your code and the operating system. And there you have more control, and but they can run kind of faster. And only then you go to the last phase where you actually deploy it to the real-time operating system, and then you do the final testing. And yeah, it's not ideal in the sense that something that works on your computer might end up not working on the simulator, and then something that works on the simulator might end up not working on the real-time operating system, so in the production phase. But, you know, that's life. And what you do in those situations is, what I like to do is to do an analysis, a root cause analysis, and figure out why did we miss this? What is different between how we are writing code and, you know, what happens in in production, because basically what you need is an extra constraint in the way you are writing the code. And if you do this root cause analysis for every such issue and you learn from it, your development style evolves to the point where these issues are exceedingly rare. And yeah, they may happen occasionally, but it's not such a big problem. So don't confuse the process of test-driven development, which typically can happen for embedded systems, for a lot of things, for real-time, for memory critical, for everything. It can happen on your computer for a lot of the things, but not for the glue code between you and between this code and the operating system. And honestly, that's a problem that's not only with real time, it's also a problem for web development, because what do we do in web development? First, we run on our computer, but then we deploy to an integration or a test machine where some things may be different. There's a web server installed that is configured in a certain way, and that might be different from the production server, and so on. And so there's a lot of work. Only it's easier for web development to harmonize these things, because we can use things like Docker and so on. And Docker basically preserves the context between these three. But you still can end up with differences. It's slightly more complicated with things that deal with real time or with embedded, because you need to be more careful about how to unplug your code that has no connection with or take the code that can be unplugged from direct connections with the operating system and kind of separate it and work on it separately. And then you have different ways of working on the different levels. Like if you're working on a piece of code that is not connected directly to the operating systems, it just does, I don't know, computations or stuff, you can do that. And then the next level is you want to write the glue code. Okay, when you write the glue code, maybe you can use test-driven development, but with something like test doubles that will simulate calls from and, well, calls to the operating system. So you can use a stub for that. But it starts to become slightly more difficult, so maybe you need a special testing framework that better simulates that. Or maybe you make that part as thin as possible. You don't write automated tests for that, but you figure out how to write the code and how to review it and all that to ensure that it's not wrong. At least it doesn't introduce any issues. But that's more a problem of testing strategy, and once you start thinking about this, you can do a lot of different stuff. And I work with people working in embedded systems. I work with people who did real-time systems. We always found ways of making some way towards this incremental approach and having more tests and more coverage and running the tests at the appropriate times and weeding out bugs earlier. Okay, but the strategy needs to be slightly more complex for these systems. With this one, I agree. Okay. But in nowadays typical system software I'm referring to, let's suppose the checks and memory required to such clauses is neglectable, so the error control mechanism is embedded in a production code without issues. Then, as you said, someone can create the TDD tests. No, someone can implement one test at a time, very important. I see some points here. TDD, in this case, is just test to verify the error control mechanism is working as expected. No. In every case, TDD is about verifying all the behaviors. Okay? So by all the behaviors, I mean even the fundamental one. I add 2 plus 3 and I get 5. That is a behavior I want to check. Why? Because I have abstracted that away in an add method. This is what the add method does. And it might look silly, but honestly, the best tests in TDD are the ones that look silly. Think about it this way. Is it silly for an accountant to write the same number in two places and compute in two different ways the result and then compare the two results? Maybe it is, but it's a very good way of making sure that you don't make errors in accounting. It's the same with test-driven development. Some of these tests will look very simple, very basic, very boring. That's good. Boring is good. We don't want a lot of surprises in software development. We want things that are boring, they just do what they are supposed to do. And the test is just stating what the function is doing. Okay? You stated that the function is to add two positive numbers and return a positive number. There are a number of ways you can do that. Property-based testing is one of them. But if you're doing this using test-driven development, the way to do that is by coming with examples. Happy path, unhappy path. So happy path is 2 plus 3 equals 5. And one test would have been enough, but I need to write the test. So it's not just test to verify the error control mechanisms is working, it's test to verify that the add method is doing what it's supposed to do. And the add method is supposed to do two different things. One is to add two numbers, and the other one is to not accept negative numbers. No, we need tests for all of those. Okay, TDD in this case is just so that's wrong. Because these error control clauses asserts are eventually testing the behavior of the function module even in production mode. No, that is not a test. What I have in the production code is a verification, and I need to test that that verification is working. It's as simple as that. Okay. So what's in the production code? The asserts, if you have asserts, the guard clauses, those are not tests. A test is the other one. Those are conditional statements. Okay, a test is when I say, given these two numbers, when I call add with these two numbers, then I expect to get this result. It's a question that I'm asking a function, and the answer should be yes or no, true or false. Does it work or it doesn't work? That's it. The TDD tests, however, in this case are created after the function's behavior has been established. No. I mean, we had the requirement, and you gave me the requirement, add two positive numbers. I analyzed that requirement. I created examples, but that was my thought process, which I showed you. And then I started writing the tests. So I did not create tests after the function's behavior has been established, I wrote one test for the first example that derived after the analysis of your requirement. So let's put it this way. I noticed that this is very hard for people to understand. Here I'm thinking about the problem. I don't care if it's one method or two methods or 5 methods or 3 classes or 10 classes. I don't care. The only thing I care is what are examples of inputs, what is the expected output. That's all. And the expected output can be a value or can be an exception. It's as simple as that. Okay? But that's all I'm thinking about. And I don't care how this will be implemented. In fact, if I were to refactor this example that I created in the previous video, as I said, I would probably have a main method, which we obviously need. In the main method, I would have some validations that would include actually all the checks. And the add method will just do add. That's it. So that would be my thing. So it's not correct that the TDD tests are created after the function's behavior has been established. That is not how I understand these words. TDD would require in theory to write first the tests. No, to write one test, implementation, refactor, one test, implementation, refactor. And then implement the error control mechanism. No. No. So we have to separate between, you are confusing things here. The error control mechanism, whatever, that is implementation. It's what the code does, okay? So it's a list of behaviors that I need to check. It's a list of examples. It's as simple as that. However, you describe the error control mechanism as part of the function which the TDD will have to test. Absolutely, yes. But this is again like I say above. Okay. So I think these are completely wrong. I'm not sure what part of the message didn't go through, but I hope with this longer explanation, more of this goes through. To my mind, these two operations seems equivalent. A, write the guard clauses and asserts and create the test to see they work. B, write the test first and then create the error mechanism such as they succeed in all tests. They are equivalent in the sense that you obtain the same result in this case, because it's a simple enough problem so that how many variations do you have for implementing this method? Probably 3, 4 that I can think of. So yeah, absolutely. The result will be the same. And also, what is the goal of TDD? Is to solve a problem. And what is the goal of writing code, as you are stating? Well, to solve a problem. So in the end, we end up with code that is hopefully working. Okay. They are equivalent in this sense. But the method is important. Not as important in this case because the method is too simple. But it is important in every case where we are dealing with slightly more complex things. Maybe we can do another example, like, I don't know, checking the password, authentication or something like that. The only difference is the context of working. Now, okay, let me read this. In the source code, we rewrite the mechanism while seeing the code per se, or the test suite code where you only see tests and no source code, they need to switch context here and there. that eventually the two approaches are equivalent, not? Well, no, because there's a different, the two approaches are very different. One of them is incremental and the other one is just, write code. And this turns out to be a very big difference because of how our brains work. That's basically what it goes through. In order for us to have a stable system. So imagine you are building this and not this, because this is too simple. You are adding a new behavior to a system that's already big and that doesn't fit in your head. Tests are a safety net that allow you to see that that system is still working correctly. So when you come and say, okay, and then the next problem is the problems that you get are not as simple usually, they are much more complex. So the whole thing in making the analysis of examples, happy path, unhappy path, and figuring out how to structure these examples, in which order to take them, this, if you do this and you figure out how to build this one step at a time, you start getting a few advantages. One advantage is that I have always working code because tests are passing. Now, is my working code always complete? No, it's only complete when we have finalized implementing all the behaviors. But always the code is working. Which means that in theory, I can always, maybe with a few extra steps, deploy a partial implementation if I need to. Right? And this tends to be important in this day and age. But it's also important when I'm working on something complex and I need to do something else for a while, go to a meeting, sleep, go home, go on a holiday. When I come back, what I see is still test passing. I know it's the next step and I can move on. So you have this pause and resume option with TDD. You have working code every 5 minutes, which means that you are always building on solid ground. And by working, I don't mean just compiling. It's provably working. It's a partial implementation of the problem, but it's provably working for that partial implementation. So that's why these two are not equivalent. Now, do all this matter for this very simple example? No, it doesn't really matter. You can probably mix it up in any way you want. You can write one test and then implement everything and then write more tests and so on. But it would just be very confusing. So following the discipline of TDD helps you have a clear mind about things. And it helps you focus very carefully on one thing at a time, which helps your mind actually be at ease. You tend to feel better, at least I do. You see that you are progressing because you have a green bar every 5 to 15 minutes and so on. So they are not equivalent in general. If yes and they are equivalent, then my approach in the comments in the previous video can be considered as TDD given someone makes, and let's say for now, keeps enabled the test for the error control mechanism, guard closes and asserts. No, absolutely not. It's still not TDD. So I'm not saying you should not be using that method, but it's not TDD. And it doesn't matter, the guard clauses don't matter. Forget about those. Those are just an implementation detail. What matters is the discipline, the process. Okay? Cool. Okay, I hope this clears things up. Now let's go a little bit on this one. Suppose you have a module with a test set of 10,000 images, which it analyzes and produces numbers, which then asserted to be as expected in an embedded device, which is mass loaded on a PC, supposing embedded computer vision case. Such tests may take hours to run in order to confirm the module. After the update of the code can still run to produce the same results on the 10K images, plus now to succeed in additional 100 images of a new case for each and update occurring into the module. All right. First of all, when we talk about tests in the context of test-driven development, okay, there's actually a there are different types of tests. So if we take, I don't have a lot of experience with embedded computer vision, so I'm not sure how this works. But I imagine there's some way to feed the images, and you can test this part. Separately. So it's a matter of separating behaviors, okay? What you are testing in your unit testing cases, in your TDD cycles, will not be the whole system necessarily. It can be parts of the system, one function, one class, one unit, okay? Basically one behavior. So it's hard to discuss this without understanding the architecture much better. But basically what I can do in such a situation is, and what I do, is to analyze the architecture and figure out how we can have a testing strategy that has as basis tests that run very fast, and then move on and on with tests that are slower, and ending up, of course, with these types of tests that will run overnight or something like that. But what I need in order to be able to develop things is very fast feedback. However, there's and I think where things start to get a bit more complicated is when you deal with AI. Because with AI systems, you need to train them, and then you need to verify that the training actually leads to better, improved results. In that situation, I don't think you can use test-driven development. It just doesn't apply. It's a completely different way of working. And so you cannot apply it to the AI part, to actually training a model and do all these kinds of things. But you can apply test-driven development on the things that are around that. So assume that is working correctly, and then test all the code that calls the model with smaller tests. And by assume it is working correctly, you are using mocks or stubs. So I'm calling that system, and instead of calling the AI system, I'm calling a stub that returns to me a value that I define, and that is the correct value. Or it returns an incorrect value, and then I need to figure out what to do. This is how we do these things. And that's a general approach for whenever you are dealing with things that cannot be easily tested versus things that can be easily tested. There are multiple such things, like random numbers, for example. Very common case. Okay, how do you run tests with random numbers? Well, you replace the random number generator with a stub, you assume you get certain values, and for those values, you check that you implemented the right things. Okay. So what I'm trying to say is that even if all the end-to-end tests will take a long time and you run them overnight, you carve pieces out where you have tests that run very fast and that you use for your test-driven development approach. Suppose I have a system or a larger module consisting of 5 such modules interconnected. I want to do one update to one module. It doesn't make sense to run all the time-consuming modules test over the modules while knowing they have got no update change. I could verify the integrated system module was in its own test, and given the effect I have embedded, cache the error and so on. Then I can go to that module, enable the test, provide the same input. Okay, so what I have a problem here. So let me read this. In this context, for me, it would make sense to disable tests regarding unaffected modules. The fact that modules already contain error control mechanism which have been tested via TDD. I can test the integrated system module and catch the errors. Sure. So let's go here. TDD presumes we have fast tests. So then we need to use optimizations. What are some of the optimizations when we don't have fast tests? Okay. And now what are some of the optimizations that we can use? One, separate things in your code in easily testable and not easily testable. Use test doubles for those to replace for tests the ones that are not easily testable. Okay, optimization number one. Optimization number two that we can use, parallelized tests. So basically what we can do is to have, in your example, instead of having one device run a sample with 10,000 tests, we buy 1,000 devices and each of them runs 10 images. Deploy the same thing on all of them, each of them runs 10 images, and we get the answer much faster. Is it worth economically? I don't know. That's another question. Run only a subset of tests. And this is not disabling. Okay, I have a problem with the term disable tests. I want to have all the tests enabled, but the test frameworks allow you to run a subset of tests based on the namespace, based on tags, based on all kinds of things. So you can figure that out. But we don't disable the tests. We run a subset. That's a different thing for me. And this is actually a very common thing. So programmers only run the tests for the current module. So this would be an example. e.g. during TDD, programmers only run the test for the current module and actually the fast tests. After the behavior is implemented, programmers run tests run all, well, all the let's say like this. After the behavior is implemented, code goes to integration, where we run all the module tests, for example, overnight. And if this works, then if all this works, promote to production and tests, etc. Whatever other tests you might have. Okay, so these are typically the optimizations that we use. So test doubles like stubs mocks, but we don't disable tests. Okay, so when you are doing your TDD cycles, you only run the fast tests, but you have to make sure that you separate your architecture and your design in such a way that your fast tests cover a lot of ground. And you may assume that some things are working, like the AI computer vision model. Okay, you assume that this is working. You write the code that assumes that is working, but that does the additional stuff. And this means you don't run for the 10,000 images or for the 100 images, but you split the problem into smaller problems, and then you do the next thing. If what you are talking about is an AI system, then there we don't do TDD. The way I understand this is, in that situation, you basically feed more training data and you test somehow that it still fits, that it falls within specific heuristics and so on. But that thing you need to run, it's a different style of working and it doesn't match this. But one way would be to, split this on different devices, parallelize as much as it makes economical sense. In this context, for me, it would make sense to disable tests regarding unaffected modules. You do this on your own. So when you are doing test-driven development, yes, because you only run the test. You don't run all the tests for the whole system, generally speaking. The fact that modules already contain error control mechanism which has been tested, yeah, but it doesn't matter. I can test the integrated system module and catch the errors. Of course, you can test everything, but the problem is how fast. And now, after all this, while everything seems to make sense to me because everything is isolated and tested, the error mechanism are embedded and working perfectly for bugs or wrong operation in the production code, I feel now somehow that this isn't TDD, although I have the impression TDD has nothing different to offer. So I feel I'm still missing something here. Very possible. So if you are coming from an AI background, then that's a whole different way of thinking. But whenever we are talking about software development, I think I've explained already that TDD is about incremental, small steps, small incremental steps. Maybe that's the thing that you are missing. Running the test suite has nothing to do with TDD. Or having a test suite has nothing to do with TDD. Or, well, it's a side effect of TDD. So it doesn't matter if you have the... So here's how we think about this. Let me just try to give you one last perspective of things. The way we try to think about this is that any change in your code might affect other parts of your code. Why do we have this assumption? Because it happens again and again. Okay. If you are perfectly certain that you can change code in one module and it does not affect another module ever at all, then sure, do whatever you want. All right. But we start from the assumption that everything we do to code can lead to bugs in unexpected places. This is why we want to have a test suite that runs throughout the whole system. Because we never know what we might introduce that is unexpected. So the ideal way would be if on every change in the code I could run all the tests, and all the tests would be extremely fast and run under 1 second. This would be the ideal situation. But we are never in this ideal situation. So then we use optimizations. And some optimizations are about the way we write the tests. Some optimizations are about which tests we run during our TDD cycles. Other optimizations are about parallelizing the tests. Other optimizations are about separating fast and slow tests. Other optimizations, which also make sense for design, are about separating the core of the application from interaction with the outside world. And this makes sense for design because the core tends to change more. Oh, actually, the interface tends to change more, and we want to leave the core more flexible. So this is why we are doing all this. Now, how many of these apply to your specific system? I don't know. But if you want to have more conversations about this, I suggest going through an actual business agreement, because it's it will be impossible to give all the details for this. Okay. So thank you, PVX215, for this very interesting question and then follow-up. I hope I've cleared up some more. Now let me end with the second comment, MudShark5393. Thank you for a nice presentation. This simple example might be different if you use a statically versus dynamically typed language. If it's statically typed, you might not even need to check for negative numbers if you use uint or similar types for the input. The compiler will hopefully not let you use improper values using type restriction. Yeah, absolutely. But the point of writing all those behaviors is that you still need to account for those. If you can account for those, or if you prefer to account for those with types, or with guard clauses, or with exceptions, or with design by contract, or it doesn't really matter. You still need to account for those. Only the difference is in if you go with using uint, unsigned int, you won't be able to write a test that also passes and that passes in -1, because the compiler probably won't let you do that, although it's worth testing. And in that case, you wouldn't write the test. For dynamically type, you probably need to add extra checks for the input argument, make sure they really are ints and not float strings or null, or if you allow those cases, define the behavior for them by adding more tests. And as I said in the beginning, that's a specific choice. I would make these types of checks, including some, even in Python, I would add types at the entry point, along with a number of validations and sanitizing data and all these types of stuff. and those will be tested there. And I prefer to leave the core of my application more flexible, which in this case would probably mean that I wouldn't even use unsigned int. Just add two things, whatever they are. All right. So this was a pretty long answer to some very interesting comments, but I hope you found this interesting. I am recording this earlier than usual because I will be in Brescia at the end of the week giving a keynote to the Working Software Conference. And before that, I'm giving a talk in Cluj. Actually, I'll be away pretty much this week. So in case anything else comes up, just know that this video was earlier than usual. Anyway, what do you think about this? Any more things that need to be clarified? I'm afraid that this example has kind of run its course. There's not much more than we can extract out of it. But what we can do is to actually do a series on over the summer for some of these techniques. Well, let me know if you found that interesting, if you have any more follow-up questions or any other questions related to design, architecture, security, whatever. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.